Okay, now we're looking at the arc length of a parametrized curve. And we have, again, dx dt and dy dt. And so if we want the arc length, really looking at this graph of what a parametric curve could look like, makes the most sense. If you think about it, again, the more you zoom in on anything, the more of a straight line that curve will eventually become. And as long as this dx and this dy are infinitely small, as long as the t that's driving this x and the t that's driving this y are infinitely small, then eventually local linearization tells us that this curve becomes a straight line. And of course, the distance formula is going to get us our length of our curve. And so this is just like the length of a curve for a non-parametrized curve, where we do the square root of 1 plus dy dt times dy, or dx dt squared and then dx on the outside. It's the same thing, but in this case we have dx dt squared plus dy dt squared, and then square root of, and then just dt on the outside. And if we were to take the dt inside, it would cancel out with these dt's here, and we would just end up with the square root of dx squared plus dy squared, because all the dt's would cancel. And so the math works out that it is just distance formula again. But let's go ahead and do an example problem as well. This is number 31 from the homework. And so for number 31, all we need to do is just say, okay, from what are our bounds? And so our bounds are 0 to 3. So we're going to go ahead and do the integral from 0 to 3 of the square root of, and dx dt squared. So we need to find dx dt. So dx dt is going to be 3 halves times 2t plus 3 to the 1 half, and then that's all over 3, and then chain rule times 2. So the 3's cancel, the 2's cancel, and then we're just left with that. So dx dt is just 2t plus 3 to the 1 half. And then dy dt is going to be 1 plus 2t over 2, which is, of course, just going to be 1 plus t. So that's dy dt. So then we need to put these in here. And so we're going to have 2t plus 3 to the 1 half, and we need to square that, plus 1 plus t squared, and then times dt. And so we have that equals from 0 to 3. The square root of this just becomes 2t plus 3, and this becomes plus t squared plus 2t plus 1, and then dt. And so we're continuing to do our algebra here on the inside. Square root of, we get t squared plus 4t plus 4 times dt. And so either we're going to use a calculator for this, or it can be differentiated on its own. And so if you look at that, you could do that as just this, square root of, and it would just be t plus 2 quantity squared dt. I think that works out right. And so you take the square root of that square, and since we're going from 0 to 3, it's just going to be from 0 to 3, it's just going to be t plus 2 dt, and we're going to get t squared over 2 plus 2t, evaluated from 3 to 0. And you can finish the problem there. But the answer key in the solutions manual, I'm sure, is there as well. But the key is, of course, just that we're taking the first, and we're taking the derivative of the x, the derivative of the y. We're squaring both of them. And then whether you have a calculator or not just depends on how easy it is to take that integral.